Okay, guys, you got your notes in front of you. We're going to look through these clearly and go through it with our calculator as well. So I want one calculator per two people in front of you, per your partnership. I want you working with your partners quite a bit today, but I only need one computer out. And when you look at your calculator, I almost do want you guys to take turns when you're dealing with your calculator today. And I'm going to have it out, I'm going to bring it in and out throughout this video. But this idea that I want you to see is we're changing it from the word that was square roots to cube roots. And now if I was to go ahead and draw a square, the best I could, let's just say this is a perfect square, right? And we talked about perfect squares, and if I said the area of my perfect square was 64, the area inside was 64, what would my side lengths be? We remember squares all have the same side, and we know how to find the area is base times height or length times width, okay? You must remember these concepts going into high school. Length or base times height or length times width, same idea, to give you the area of what's inside, okay? I love to give the example if I wanted to put new carpet in my room, say this is my room, I would have to measure from one side of the wall to another, and then from like my door to the whiteboard, and I would multiply those two numbers to figure out how much square feet of carpet I would need, of square feet. Now, look at this image compared to this image, you can tell is three-dimensional, all right? So this is a perfect cube, all right? Think of like an ice cube or a box. It's a perfect cube. Now, I don't know if you've learned yet what volume is, and maybe you have from seventh grade, you should remember, but it's okay if you haven't, to figure out the volume of how much can fit inside this box, how much of whatever you can fit inside this box. I'm going to go ahead and write this out. It's actually called for the volume, which is same idea as area for a 2D. This is two-dimensional. The volume is the same idea, how much can fit in. This one was how much could fit inside this square. This one's how much could fit inside this box. And the volume formula is length times width times height. And they write it like this too. They always do a cursive L in the math book. And when you see it later on in life, you're going to see it that way. Length times width times height. Now, first of all, length times width, we know what that is. That's the area. Length times width. We just talked about that. But then we include the height because this is no longer a two-dimensional object. It's three-dimensional. Now, with a square, how would you figure out the volume of this? The length, you could say this equals the length, this equals the width, and this equals the height. Okay, you see what I did there? And the S means side. So S, 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 that means the sides. So guess what I'm going to do? I'm going to multiply all three of them. So if I did volume equals side times side times side. Well, you remember from our first 2 weeks of this school year, the first 2 weeks of this school year, for this problem, you could figure this out. What if I said it was x times x times x? What would that equal? That would equal x to the third power. X to the third, because isn't there an invisible one here, here, here? And what are you supposed to do with those? You're supposed to add them. Okay? So we're going to the third power. This was to the second power. Remember, 8 squared equals 64? Now we're going to kick it up a notch, and we're going to use our calculator for this. But I just wanted to go through why this is to the third power. Why these are called cube roots? Because it's something times itself 3 times. Not 2 times, but 3 times. And why is it called a cube root? Because that's the formula for your volume. Length times width times height. But your length, width, and height are all the same thing. So really it's side times side times side. Okay? Cool, cool, cool. Hopefully that gives you a little bit of an explanation. If not, that's okay. Let's go into this part here where we're going to start thinking about what these items are. What to the third power? So 1 times 1 times 1. Again, that's what we're doing, right? 1 times 1 times 1 is 1. All right? That's pretty simple. Let's do 2. 2 times 2 times 2. Okay? A little different. 2 times 2 times 2. Well, 2 times 2 is 4, and then 4 times 2 is 8. Make sure you understand that. This is not 6. Some people look at this and say, oh, that's 6, because it's 3 times 2. Nope. It's 2 times 2, which is 4, and then you got to multiply that 4 times that last 2. All right, let's do the 3. 3 times 3 is 9. All right, 9. 3 times 3 is 9. And then 9 times 3, 27. Okay? Now, let's use our calculator to figure out these ones because they're going to get higher numbers. And I want you to be able to, I really want you getting good at using the calculator. So, first of all, why don't you use the calculator now? A is going to use the calculator first. And A is going to look at this and go, okay, 4. If I click this button right here, 4. Okay? Now I'm going to get a little fancier and I want you to see what's happening. I'm going to hit this button A to the B. If I hit that button, this one right here, it bumps it up to an exponent, and I can give it whatever exponent value I want. Well, I want it to the third, and I go boom, 3. And what do I get? 64. So that's the next one, 64. Okay? Now B's turn. I want B using the calculator. B, get that calculator in front of you, and go ahead and figure out what 5 to the third is. So click 5, and click this button here. Could you just do this 5 times 5 times 5? Of course, and get 125, which is your answer. But I do want you to get good at using your calculator as well. So 5 to the, hit this button, third power is also 125. All right, you guys can take turns with the calculator or you can just get through it, but I want you guys going all the way to 10. I'll give you guys about 30 seconds. Go for it. 6 to the third is 216. 343. 512. 729. And 1000. Okay, so you filled out your whole sheet, hopefully, all the way down. And these are all your cubes, pretty much, your values. Now, let's get into another part of our calculator. Look at the way this looks, okay? So this looks a little different. If we're taking a look at this, now we can look at this. What's this little 3 hanging out on the outside? We know what a square root is. Like if that 3 wasn't there, square root of 27, we could plug that in and we would say square root of 27 is, okay, 5.2, right? We could round that up to 5.2. We know that, but that 3 changes everything. So right now, you're going to try to figure out what number to the third power equals 0. 0 is the easiest one. What number to the third power equals 1? And you're going to notice these numbers. What do you notice right now looking at these numbers? From here, you see all these numbers here? And look at all these numbers here. Okay? So those numbers do correlate, but I want you to see how to use the calculator as well. Okay? What if I click this guy instead? Watch what I do. Boom. Now, this is a trip. Look at this calculator. You have the exponent here that I can put out there, whatever it is, and we know it's going to be 3. And it kind of doesn't show it, which is kind of annoying. I think if I move it out a little bit, no, that doesn't change. But there's a 3 there. I don't know if it shows on yours. And then go inside and put 1. What is the cube root of 1? 1. 1 times 1 times 1 equals 1. Now let's keep changing it up. What if I did 8? Isn't the cube root of 8? So basically we're working backwards now, right? 8 right here equals 2 times 2 times 2. So it's figuring out what number to the third power equals 8. All right, the cube root of 8 is 2. What about 27? What number times itself 3 times equals 27? And it's 3. So you can see the pattern. Hopefully you can see the pattern happening. I just wanted you to get good at these calculator using these 2 buttons here because you get to use those come test time. Now, let's just look at here. 64 cubed. That's how we know it's cubed with that 3 on the outside. 64 cubed equals 4. 125 cubed equals 5. 216 cubed equals 6. What did I do wrong? What did I do wrong? Okay, no, this is 7. Sorry, 343 is going to be 7. 512 is going to be 8. 729, 9, and 1010. Okay, So I wanted to go over this real quick. We're not going to do many equations with this, but you do need to be aware of stuff like this. Okay, sometimes you'll see this thrown at you, and you have to know what it looks like and what it means. So anything with the 3 on the outside and then a square root sign means what to the third power? To the third power. 4 times 4 times 4 equals that 64. So the cube root, not the square root, but the cube root of 64 is 4. Okay? Cool, guys. Now, take out your note sheet. Flip it over, actually. I haven't made my copies yet, but flip it over. Now we're going to talk about what we did yesterday. Let's go ahead and have that calculator out. We're going to share the calculator. Again, I only want one per group. And when you guys are working together, I want you guys kind of writing this out and working together with the calculator. So let's go over how to do this. Again, from yesterday, what if I said it's 15 plus x squared equals 65? Okay? So go ahead and if you need to, use the calculator, but I want to get a final answer in this box. Okay? First step, second step, final either rounding. If you have to round, I'll put this here. Round to 10th. Okay? Let's do a couple of these together. All right, first step. We're going to subtract 15 to both sides. All right, then I get x squared equals 50. Put that in this box. Now I have x squared equals 50. Okay, then again, what would you say with this one? You said move your constant to the right. Move the 15 to the right by subtracting. Okay, then what would you do here? To get rid of the squared, I would square root both sides, and I would get the calculator involved. We're not doing cube roots anymore, clear all. I'm going to go square root of 50, and I would get 7.07. I have no problem you writing that down, 7.07. So here it's going to be x equals 7.07. Now in this box, you could write that out, 7.07. But remember, it says round to the 10th. Our 10th value is here. So we're going to look to the right of it. 5 or more, let it soar, or 5 or more, raise the score. You remember, 4 or less, let it rest, okay? We're going to raise the score, so your final answer is going to be 7.1. All right, you guys? Great job. Now let's do one that's a little bit different, okay? I'm going to go ahead and throw this at you. I'm going to say 3 squared plus x squared equals 10 squared. And these are the kinds of questions you're going to see later on next week. All right. So let me get this out of your way. Write this out. When you look at this, I would love for you to set this up properly if you can. And first step, I would say now your first step is to square the numbers. Square the numbers. You should know what 3 squared is. You should know what 10 squared is. So 3 squared is 9. We're going to put, we can't do anything to x squared, right? And then 10 squared is 100. All right. So go ahead and put that out here. 9 plus x squared equals 100. Now what's your next step? Let's move our constant to the right. Let's move our constant to the right. Okay. So then I have x squared equals 91. Okay. And then I'm going to write that out. X squared equals 91. What's my last step? I want to square root both sides. So go ahead and square root. Let's bring this into play here. We're going to change this up. We're going to change it from that to 91. And I get 9.53. I have no problem if you want to write it out and look at it and examine it. What's this going to change to if I say round to the 10th? Round to the 10th. Again, the 10th is here. If it said round to the 100th, you would have to look at this, the 1000th, the spot next to it. But we're rounding to the 10th, so it's going to be 9.5. Great job. Great job. All right, let's keep it going. Let's do 2 more, and then we're going to do whiteboards. All right, let's go. Let's go, let's go, let's go. Let me give you another one. What if I said 3 squared again plus 5 squared equals x squared? First step, just like we did up here, why don't you go ahead and square those numbers for me? If you think you can square these numbers for me, This next step, I really want you to write this out properly, making sure you know what to do. There's no constants needing to move over. Let me give you that clue, okay? So this is going to be 9. All right, 9 plus 25 equals x squared. And then from there, you're going to go ahead and what? This is the big part. You're not going to move any constants over. All of your constants are on the same side. So I'm going to draw my little mustache, and I'm going to combine like terms. All right? Combine like. Don't forget to do that. All right? We're so used to moving constants to the right or to the left by subtraction or addition, but combining like terms is very important. So 25 plus 9 is going to be 34. Now let's move that over here. 34 equals x squared. Square root both sides. And the square root of 34 is going to be, put this over here, I get 5.83. X equals 5.83. Does that 3 do anything to the 8? Nope. So my answer is x equals 5.8. All right, you ready to do this one on your own? I think you can handle it. Next one on your own. Let's see what you can do. Using your calculator, I'm going to check on you guys in a second. Here's your problem. I'm giving you a big one. All right. If you need to use your calculator for any of this, go for it. Let me give you a clue. 12 squared is 144. I should have given you an easier one, but it's okay. You guys can get through this. All right, first step. 16 plus x squared equals 144. 12 squared is 144. 4 squared is 16. All right. Now, if I go through 144, all right. Now are you combining like terms here? No, you are going to move your constant over, just like this one here. X squared equals, is that 28? 128. And then the last step, let's go ahead and plug that in. Square root of 128 is going to be 11.3. Oh, I kind of jumped ahead. 11.3 what? 1, which just becomes 11.3. Hopefully you got that, okay? Keep that calculator out. Let's go ahead and get into our whiteboards. So A's, can you get the whiteboard? B's, go ahead and get the calculator in front of you. All right, now that you have your whiteboard in front of you, let's go ahead and go through this. So making sure you understand that A writes, B talks, and when B is talking, make sure it's first step, second step, okay? When you're talking, if you want to see or look up here to get any help, move constant over to the right, maybe by subtraction, all right? Combine like terms could be another step too. These are never going to be together though, okay? And then at the end, you're square rooting and then eventually rounding, correct? All right, first question. Let's see what you guys can do. We're going to go through this. Take your time. We'll give you about 30, 45 seconds, maybe even a minute for each problem. All right, first problem, A is writing. A is writing. Go for it, A. B is talking and using the calculator. Go for it, guys. All right, let's check our work. So 25 plus x squared equals 81, right? So then I would say square the numbers first. That would be another one you could put up here. Square the numbers first. First step, square the numbers, all right? We could put that up there. I could put that right there. Square numbers, because that's going to come up a lot. Square numbers, all right? So we squared them. Then we're going to subtract 25. All right, from 81, we're going to get x squared equals 56. Then from there, we're going to go ahead and plug it into our calculator. If I did 56, 7.48. 7.48. If I said round to the 10th, and we're always rounding to the 10th right now. I will sometimes say round to the 100th, but for now, we're just always going to round to the 10th. Square root both sides, you get x equals 7.5. Why is it 7.5? Because this 8 bumps it up. All right, switchboards, erase. Let's keep it going. Switchboards and erase. All right, next problem. Let's keep it going. This is now A and B are switching. B writes, A talks. Here's your question. 8 squared plus x squared equals 11 squared. All right, go for that for me, please. Go ahead and take care of that. So as you work on this is going to be squaring the numbers first. All right. Then you're going to move your constant to the right. Move your constant to the right. As you do that, you're going to get x squared equals 57. Interesting. We had a very similar number there. That's funny. So last time was at 56 right there. So then if I'm going to square root 57, all right, so I have this here. I'm going to get 7.54. 7.54. So to make sure you know what's going on, you're going to square root both sides. Again, 7.54, which you can just leave it at 7.5. It's almost going to rise to 7.6, but not quite because that's a 4. All right, erase your boards. Let's do another couple. Let's go. All right, make sure you're talking to each other. Now I'm going to do something where it's going to involve combining like terms. Excuse me. 2 squared. All right, go for it, guys. What are you going to do? Square your numbers first. And then square root both sides. We're good to go. So the square root of 29, 5.38. 5.38. Marissa, could I bump that up? You sure can. To 5.4. Okay? 5.4. Let's keep it going. Let's do one more. Ooh, this one's going to need your calculator. All right, do the best you can with this one. All right, go for it. I get 81 plus 196 equals x squared. I combine like terms. I'm going to get 277 equals x squared. I'm going to square root both sides. Okay, I'm going to get 16.664, but we're going to use 16.6. Okay. All right, guys, go ahead and get into your rally coach with your partners. Do the best you can. I'm really encouraged to see how you guys are going to do on this.